Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. So, in the lecture series, based on previously asked questions in university exam, I am trying to cover the Unit 1 questions in these lectures. So, some questions which are marked here already covered in previous 2 videos. Now I am trying to cover some problems. Okay, now the problems which are commonly asked in the university exams. Support reaction, for finding out the support reaction. This is the very common question. Again and again it is coming in the exam. Every time you will find a question for finding out the support reaction. Beam is loaded either with the point load UDL or UBL, okay, and supports are there. Find out the support reactions for this. Okay. So, what is a beam? This part is already available in my videos on AKGEC YouTube channel. What are the different kinds of supports? What are the different kinds of loads? All these things already discussed in the videos in very much detail. So, I am not going in the detail because my purpose of these videos are not covering the syllabus. My purpose is how to write in exam. That is what exactly the purpose is. Okay. So, that is why you may be getting good marks. Okay. So, the question is a beam 8 meter of length, 8 meter is there, yes, 8 meter is there, is hinged at A, mentioned over here, it is hinged and at an hinged at A, supported on roller over a smooth surface inclined at an angle 30 degree. So, here there is a roller support, here it is a hinged support. Okay. The beam is loaded as shown in the figure. Determine the support reaction. Very good question, simple one. As it is known to you, I consider that you are knowing if there is a hinge support, then hinge support, if I am replacing it, it will be replaced by two reaction forces RAX and RA by, in case of hinge support. Am I clear to? If you are not clear to this, you may go through the video. थोड़ा सा बता देता हूँ. If it is hinged here, then what possibility is there? If it is hinged here, okay, pin है, rotate कर सकता है, ठीक है, but is it moving in X or Y direction? No, if it is hinged. So, against these two restrictions, two reaction forces. Roller, in case of roller, the support reaction will be perpendicular to the surface at which the roller is placed, RB. Okay, am I clear? So, angle will be how much? I consider that this angle will be 30 degree or horizontal angle will be 30 degree. What it will be? Okay, I think this will be 30 degree. Please be sure this will be 30 degree, na? Because the plane is inclined to 30 degree with the horizontal. So, obviously, the perpendicular reaction RB on the plane will be inclined to 30 degree from the vertical plane. Okay. So, here the component will be RB cos 30, we know very good. This is RB sin 30. So, the first job is done. Now, we are available only with the forces. And if I have to define the equilibrium of any body in a two-dimensional force system, what I have to do? I have to apply the equilibrium equations. So, the very first, the sigma fx equals to 0. Sigma fx equal to 0. What does it mean? We are knowing very well. The algebraic sum of all the forces in x direction. So, now I am starting my equation from the left side. Here the force is RAX. Positive लूंगा, yes, it will be taken as positive because plus x की direction में. Okay. Then 10 kilonewton, it is in bidirection, no issue at all. 8 kilonewton, it is inclined by 45 degree. So it is also having two component. The one component will be 8 cos 45. Then again I am coming to the 10 kilonewton bidirection mein, no need to write in the x direction. Now I am coming to the point B, and at this point there is a horizontal force which is RB sin 30, but the direction is opposite. So minus RB sin 30 equals to 0. Please check the equation. You must be comfortable. You must be ensured that the equation is correct. Okay. Is there any issue with this equation? No issue at all. Okay. Now I am writing the second equation of equilibrium. Sigma Fy equal to 0. Sigma Fy. So sigma Fy equal to 0 means algebraic sum of all the forces in bidirection. Starting again from the point A, there is a vertical force R A Y. Then minus 10 नीचे की तरफ है minus 8 sin 45. Okay, minus 10 plus RB cos 30 equals to 0. चेक कर लें, कंफर्म हो लें, बिल्कुल श्योर हो जाएं, so that you will be able to write the equations. Please make yourself comfortable. Okay. I hope both these equations are clear to you. I don't know how people are making mistakes, but so be comfortable. I hope both the equations. How many unknowns are there? 1, 2, 3. So is it possible to find out 3 unknown variables by 2 equations? No, definitely no. Mathematics doesn't support this. So we need third equation also. Third equation, obviously if I am defining the equilibrium, then not only the translational equilibrium, the rotational equilibrium will also come in picture. So sigma ma equals to 0. Either sigma ma equals to 0, or if you want, then I can write the equation. I always suggest that choose the point jiske about you are comfortable to write the equation. Because at point B, we are having one inclined force. So to eliminate that difficulty, we can write about any point. There is no restriction. It is not necessary कि A या B के ही लिखना है. मैं इस plane में किसी भी point के about I can write the equation. But I am always suggesting when you are attempting the question in exam, then choose the point जहाँ पर difficulty level कम हो. So your equation will be always correct. So I am choosing. Earlier I was writing point A, B, because B per we are having one inclined force. So eliminate this. Okay. Point B. Let's start from the point B. Sigma MB equal to 0 means algebraic sum of all the moments due to various forces about point B equals to 0. मतलब B point के about जितनी भी rotational tendencies होंगी उन सभी का algebraic sum 0. Okay, so let's consider the forces. Forces are creating the rotational tendency. So force, what is the first force available at point B? That is RB. And moment is force into perpendicular distance. Force into perpendicular distance. So definitely force RB, but perpendicular distance of this force from point B is 0. So there will be no moment because of RB. Now I am coming to the second force, 10 kilonewton. 10 kilonewton. How far it is? What is the perpendicular distance of 10 kilonewton from 1 meter? Oh, this is the distance from B. So 10 into 1. 10 into 1. What will be the rotational tendency? Anti-clockwise. Okay. So positive I am taking. Now I am coming to this. It is having two component. One is this, another one is this. This component which is 8 cos 45. If I extend this line, it is passing through from point B. So there will be no rotational tendency because of 8 cos 45, because the perpendicular distance of this is 0. Now this component 8 sin 45. So 8 sin 45, I am writing 8 sin 45. This is the force. How much is the perpendicular distance of this? So 1 plus 3. 1 plus 3 is into 4. Okay. Am I clear? Okay. Now I am coming to the another 10 kilonewton force. What is the distance of this? 6. So 10 into 6. 10 into 6. RAX. Again RAX is passing through B. So there will be no perpendicular distance. So no rotational tendency. RAY, the perpendicular distance of RAY is 8 from point B, and the tendency of rotation will be clockwise. Just check out the equation. 10 into 1, 10 into 1, 8 sin 45 into 4, 10 into 6, RA into 8. So, okay, by solving these three equations, we will be finding out the answers, and answers will be RAY. Are you calculating, or I have to calculate? Okay, I am writing you the final answer for your reference. 11.58 kilonewton RAX, how much it is? It is 2.47 kilonewton, and RB equals to 16.255 kilonewton. So these are the final answers for the question. So I hope it is a very simple question for you, okay, to deal with. Okay, am I clear? So check the equations again. Equations are perfect. Answers you will be finding out. Calculator properly use kare. No need to make any sort of hurry. Okay. Then I am covering the second question. A composite bar of uniform cross section area 200 mm square consists of an aluminium section rigidly fastened between a bronze section and a steel section. Okay. Axial loads are applied at the positions indicated. Determine the axial load P to make it in equilibrium. Stress in each section and the total length in of the bar. Okay. Other type of question I am taking here. Okay, so that's why composite bar. Why we are calling it composite bar? Composite bar we are calling because it is made up of bronze, aluminium, and steel. So modulus of elasticity for different materials are given here. What we have to find out? We have to first find out the P. So for the equilibrium of this bar, we can write that minus 100 plus 35 minus 30 plus P equals to 0. What it is coming out? P is how much? P is coming out 95 kilonewton. Now, what else is asked? Stress in each section. Stress in each section. So let's consider one by one sections. Okay. First, I am considering the section bronze. Bronze. What is the length of this? 200 mm. What is the force over it? 100 kilonewton. So obviously for any deformation, this side of the bronze section must be subjected to 100 kilonewton. Okay. So stress can we find out? Yes, stress we can find out because what is given over here? The area of cross section. Area of cross section for the entire bar. It is 200 mm square. 200 mm square. So finding out the stress in bronze, what is the load? We can write the P upon A, and P here is 100 kilonewton, 100 kilonewton, and A is 200 mm square. You can convert this into meters. So 10 to the power minus 3 square. So you will be getting the stress. Can you make the calculation? Can you make the calculation for finding out the stress? Yes? Why not? You can make, na? Yes. So how much it is? It is available 0.5 into 10 to the power 9 Newton per meter square. Now for finding out the change in length, stress, done. Total change निकालना है. So for finding out the total change, means total change in length, that will be the sum of, by the principle of superposition, delta L1 plus delta L2 plus delta L3. Delta L1 क्या है यहाँ पर? Delta L1 is the change in length of bronze. So delta LB I am finding out. How much it will be? By this equation also we can write the formula for elongation is PL upon AE. P is how much? P known hai. P we are knowing. It is 100 into 10 to the power 3. L is how much? 200 millimeter में है. So 200 into 10 to the power minus 3. A 200 into 10 to the power minus 3 square. Okay. A. And E is how much? E is how much? E bronze 100 gigapascal. So 100 into 10 to the power 9. So by this way you will be finding out the delta LB. Okay. Okay, am I all right? So what will be the answer? The answer will be 10 to the power minus 3 meters, or you can say it is 1 millimeter. Now I am coming to the second part of this, which is made up of aluminium. What is the length of this? 300. Load is how much? Now this 100, if I am shifting this force to here, this is 100. So on this plane, the net force will be 65 kilonewton. So obviously the other side of this must be subjected to 65 kilonewton. 65 kilonewton. Am I right? Okay. This side of the aluminium plane must be subjected to 65 kilonewton. So if I am clear with this, okay, how this is 65, then again I have to repeat the same thing for finding out stress. Again, P upon A. P क्या है यहाँ पर? 65 kilonewton. A क्या है? 200 millimeter square. So by writing all these in the similar manner, you will be finding out the answer, which is how much? by putting these, P क्या रखेंगे यहाँ पर? P will be 65. A same है because the cross section is uniform. So by doing this, you will be finding out the answer. Are you calculating? Are you calculating? No? So I am writing the answer for your reference. You can match your answer with this. The stress will be, this is Newton per meter. And delta L कितना होगा? For finding out delta L in aluminium, PL upon AE. P कितना? 65 kilonewton. L कितना? Aluminium की length, it is 300 mm. A 200 millimeter square. E aluminium के लिए. So that is 70 gigapascal. By doing all this, by putting all these values which I am telling to you, you will be finding out the delta L for aluminium, which is 1.39 mm. Okay, am I clear? Now I am coming to the third. Third one is the steel, and steel is 150 mm. Force कितना है? P कितना निकाला? P is 95 kilonewton on this plane. So obviously this plane of steel must be subjected to 95 kilonewton. So now I know the P for the steel. P कितना है? 95 kilonewton. A 200 mm square. So you will be able to find out the steel के लिए मैं लिख सकता हूं यहाँ PS upon AS. Okay, answer आप निकाल सकते हैं. And similarly the delta L in the steel, delta L in steel क्या लिख दूं मैं? P L upon A E. Like this you can write. ठीक है ना? That will be better. Okay. Similarly here also bronze के संग B लगा दें, aluminium के संग AL लगा दें. ठीक है ना? So like this you can write. Can you calculate the answers? What are these? Sigma S कितना आया? Sigma S is 0.475 into 10 to the power 9 Newton per meter square. और delta LS कितना आया? How much is the delta LS? It is coming out 0.35 millimeter. So that's the way you have to do. Now you have to find out the total length change. So delta L B, delta L AL, delta L S, add all these. So you will be finding the final answer. So you have to do the question in this particular manner. If you are doing in this manner, step by step, you are writing all the procedure, then definitely you will be getting the 100% marks. So thank you very much for watching the video. In the next video, I will be covering some more problems based on previously asked question in university exam. Thank you very much.